Okay, Bismillahirrahmanirrahim. Fifth question. This is basically from um, June 2014's variant 13. Okay. Acha bacho, it says a function f is such that f of x is this. We have been given the domain. It says find an expression for f dash of x. So this f dash of x is actually the derivative of this f of x. So I'll write it first of all 15 into 2x plus 3 raised to power minus 1 so that I can differentiate it. And now I can differentiate this. So I'll be writing it as f dash of x. This is 15 into minus 1, that is minus 15. Then you have 2x plus 3 raised to power minus 2 times this 2. That is the derivative of 2x plus 3. So this is minus 30 over 2x plus 3 whole square. That is your, um, I mean, derivative f dash of x. Okay. So you people are absolutely right. For the second part, it says use your result to explain why f has an inverse. So we can only have the inverse if within the given domain, your function is a one-to-one function. And I think in fact, there is no turning point on it because once you put that equal to 0 to get the x coordinate of that turning point, so this thing will be multiplied by the 0 and you will not be getting any solution to this equation because all this term in x will be 0 over here. Okay. So since there is no turning point, there is no turning point. Okay. There is no turning point, meaning this is a one-to-one function. So a function can have its inverse if it's a one-to-one function. So that completes the answer to this part one. Then it says find an expression for f inverse of x and state the domain and range of f inverse. Now writing the domain and range is really easy of this f inverse if you determine the domain and range for the function itself. So we have the domain, here is the domain. So that means we are done with the range of the inverse because the domain of the function is the inverse, I mean the range of the inverse. Let's see what is the range of this f of f, okay? So we need to find, since it is a one-to-one function, there is no turning point. So we need to have f of 0 and we need to have f of 6. So f of 0 is, guys, 5. You can see that is 5. And f of 6 is 1. So that means the range of the function is between 1 and 5. So this will become the domain for the inverse. So let's write down the inverse first of all, okay? And you people know that when you have to write the inverse, you put your function equal to y. So that is 15 over 2x plus 3, that is equal to y. So you have 2xy plus 3y equal to 15. 2xy is equal to 15 minus 3y, and your x is 15 minus 3y over 2. Finally, the f inverse of x is 15 minus 3x over 2. Now we have to give the domain and the range. So the domain is for f inverse, the domain is going to be this is going to be the domain that is between 1 and 5, and for the range, this is going to be the range for this. So that is going to be, you will write it as f inverse is going to be between 0 and 6. I hope you got it. Yes, bacho?
Yes, sir.
Okay, so remember, I'm telling you again, the domain of the function is the range of its inverse, and the range of the function is the domain of its inverse. Okay, so we move on to the next question now. That is question number 6. Okay, now this question is not about the differentiation. This is Okay, I think the part A is something related to the differentiation because it says a curve is such that dy by dx. Let me put this up a bit up and have some space for working here. I'm covering this second part because this is related to integration. That is not our topic of the day. So, guys, we have dy by dx, okay, which is given as 12 over under root 4x plus a. And there is a point P, which is 2, 1, 2, 14, lies on the curve, and the normal to the curve at the point P is this. So now this is the equation of the normal, that is 3y plus x equal to 5. I want to write this in the form y equal to mx plus c so that I can see what is its gradient. So 3y is equal to minus x plus 5 and your y is equal to minus 1 over 3x and then plus 5 over 3. So that means the gradient of the normal is minus 1 over 3. So guys, what will be the gradient of the gradient of the tangent then? Hmm? Yeah, that would be 3 because the tangent and the normal, they are perpendicular to each other. So that means this dy by dx can be kept equal to 3. And we can put this x as 2 here. ठीक है ना? So this is going to be 8 plus a. Because the tangent, for example, if this was a curve here and you see this is your tangent here, okay, and this would be the normal here. So you were given the equation of the normal, and from that we determine the gradient of the normal and then the gradient of the tangent because they are perpendicular to each other and their gradients are the negative reciprocals of each other. Okay, so guys, let's simplify this. I'll be doing the cross multiplication, that is under root 8 plus a, that is equal to 4. We square both the sides and we have 16, and therefore your a is going to be 8. That is the value, the required. Oh, so we have to show that a equal to 8. So by the way, we have shown that. Okay, let's go to the next paper. So this is the ninth question, the same paper. It said the base of a cuboid has sides of length x and 3x. Let me try to draw a cuboid here. So there is a cuboid like this, maybe. Okay, let's join them quickly. So this is a kind of a cuboid. Okay, so it says it has the sides x by 3x. Okay, and the volume of the cuboid is 288. Show that the total surface area of the cuboid is given by this. Now you can suppose that this height is h over here, है ना? So can I say the length into the width into the depth, that is equal to the volume, which is 288, है ना? That is 288. So, oh, sorry, this is x. Why did I write 3? This is x into 3x into this. So you have 3x square h, that is equal to 288. Okay? So, this would give you. Now, can you see that this is an exam question? Is not asking you to write h in terms of x. So you had to think it yourself because when you had to write the area, so let me just show you that why we are doing this. Okay, this is 3 nines are and 3 sixes are, है ना? Is that 96 over x square? Yes. है ना? 96 over x square. Guys, when you have to find the surface area, so you see the surface area of a cuboid is going to be 2 times length into the width plus 2 times length into the depth plus 2 times width into the depth. So that has to be now twice length into width, that is 3x square. Okay, then twice length into this, so that is 2xh. and then twice, and this is going to be 6xh. You can see that your area is purely in terms of x. So this is 6x squared plus 8xh. So now you need to change this. You need to get rid of this h from here. So that is going to be 6x squared plus 8x times 96 over x squared. So x cancel by this. So we have this 6x squared plus 768 over x. So this is all your O-level mathematics. And please see that again, he didn't ask you to write x, yeah, h in terms of x using this volume. So you have to think it yourself that how to handle this. Okay? Can I go to the second part now? क्यों भाई?
Yes, sir.
Okay, now let's go to the second part. Now in the second part it says we have to, given that x can vary, find the stationary value of A and determine its nature. So he's asking so many things at what glance, okay? First of all, you need to find dA by dx, okay? You need to find dA by dx, and obviously before you had to differentiate this, you should write it as 6x squared plus 768 x raised to power minus 1. Now I can differentiate this, okay? So this is 12x and minus 768 x is per minus 2. So that goes down here, x squared. And I put that equal to 0. So this becomes 12x equals 768 over x squared. So 12x cubed. Please someone tell me, what do we get from this? X is equal to the cube root of this 768 over 12. So what is this x?
4.
4. Okay. So this is 4. So we get x equal to 4. So we have found this x. Now we have to find the stationary value of A. So you put that into this equation here. Please tell me, what do you get? 6 into 4 square plus 768 over 4. So what is this?
288.
288. Okay, so that is the area. And now let's determine that if this is a maximum or the minimum area. So you need to differentiate this again. Okay, so let's differentiate this again. So that is going to be d2a by dx squared. That is 12. Okay, so I'll be writing it as here as 12x and minus 768 x raised to power minus 2. Okay, so that I can differentiate it. So this is going to be 12 plus 768 into 2 over x cube. I will not be wasting my time on simplifying this, and I would say that at x equal to 4, this d2a by dx square is going to give me a positive value because all of them are positive, okay? So therefore, this 288 is the minimum area. That is the minimum surface area. That is how you do that. Okay, this question is from June 15 and it is variant 11 and it is question number 2. Okay, question number 2. So guys, we are given that the diagram shows the curve y equal to 2x squared, the point x which is minus 2, 0. The point P is P comma 0. The point Q lies on the curve and PQ is parallel to the y-axis. Okay, so bacho, he's trying to be clever with hiding the coordinates of Q. So let's write them quickly. So the coordinates of Q should be P comma 2P square. That is the first thing that will lead you to the solution of this this part 1. So what do you think? What is the length of this P?
2p square कहाँ से आया?
Beta, because you the equation putter y equal to 2x square. So you put x as P. So what will be your y? So that is P comma 2P square. So बच्चों, बच्चा लोग अभी तुम हमको बताएगा कि if can I say that this length is 2p square? Yes.
G, sir.
Okay, and then what is this length xp? This length.
P plus 2.
Very good, because this much is p and this much is 2. So this is going to be p plus 2. So there you go, you get the area. It is half into the base, which is p plus 2, into the height, which is 2p square. So here is the area. I can write it as p cube plus 2p square. That is the area. Okay, now it says the point P moves along the x-axis at a constant rate of 0.02 units per second. So the point P is moving, okay? So that means we are given the dx by dt. That is 0.02, okay? It says, okay, now find the rate at which A is increasing. So we have to find dA by dt. Okay. At what time? When your P is equal to 2. Okay. So let's find first of all dA by dP from here. Okay. So here is dA by dP, which is 3p square plus 4p. You put that p into it, so you have dA by dP, that is 3 into 4, 12 plus 8. So that is equal to 20. So now we can find the required thing through establishing a chain here. So we have to find dA by dt. So that is dA by dt. So I'll be writing, what should I write here? X here. This is your, now you see this P is basically representing your X. So you should allow me to write this as,
Sir, DP आएगा ना?
yeah, if you write here dp, then you can write here dp, and you can assume that this is your dp by dt. Okay, because p is basically representing the x coordinate. Can you see that this is at this place of the x coordinate here? Okay, so that is how you get, so this is where he has tried to confuse you people. So dA by dP, that is going to be 20 times dP by dt, that is 0.02. So you have 4 units square per second. That is your dA by dt. Okay? This is 0.4. I was doing that mentally and I'm really making some silly mistakes these days. Okay, let me try this. Let me try this question for you guys. This says a piece of wire of length 24 cm is bent to form the perimeter of a sector of a circle of radius r. So you people are going to get a kind of a sector here. Okay, so we know that its perimeter is 24. If this is r, and if this is your theta, so this means this is going to be r theta. Can I say r plus r theta, that is 24, and your r theta is going to be 24 minus 2r, है ना? And then your theta is going to be, you see, this is what you have to do yourself. Examiner is not giving you any clue that how to get to that area over there, okay? Because when you write the formula for the area of a sector, guys, that is simply half r square theta. You see that? And here you have theta. You can't see any theta over here. So that is the clue for you that you need to get theta in terms of r by using all this given information over here. Okay. So now we can replace this theta in this area with this 24 minus 2r over r. So this will give you the required equation. Your part 1 then will be done as A, that is area of the sector, is going to be half r square into 24 minus 2r over r. So you see this r is cancelled by this square, and then there is a 2, so this would become 12r and then minus r square. So you get 3 marks for recalling your O-level maths. ठीक है. And then there is a part related to your uh, what do we say, quadratics chapter. Okay, it says you have to write this in this the second part, so we have to complete the square. So you see, that is how your paper questions are, where the things are mixed together. So let's do that second part quickly. You have this a as um, let me write it as minus r square and then plus 12r. When you have to complete the square, make sure your square terms coefficient is only 1, not even minus 1. So we will be taking that minus common. This is r square minus 12r, okay? And then we can complete the square. So this is half of 12 is 6. So you add 6 square and you subtract 6 square. This is minus, all of this gives you r minus 6 whole square. Okay. And then this is going to be minus into this minus will make it plus 36. So this is going to be 36 minus r minus 6 whole square. You can have a rough sketch of this in your mind, that this is going to be 6 comma 36. So the sharper students, they got an idea that the area is going to be maximum when your r is 6. Okay. Now, in the third part, it says, given that r can vary, state the greatest value of a and find the corresponding angle of the sector. Now, some of you might start differentiating it to get to that r, and then you see, like even if you differentiate this, let's do that just for the case of, for the sake of your reinforcement here. If I find that dA by dr, you see that I get 12 minus 2r, and when I put that equal to 0, I get r equal to 6. This r equal to 6 is the same as the 6 over here. Do you see that? So differentiation gives the coordinates of the turning point more quickly as compared to any other method. So it says, given that r can vary, state the greatest value of a. So we have already done that in part 2. The greatest value of the area is 36. Okay. And then it says, find the corresponding angle of the sector. So corresponding angle of the sector. So remember, you had developed an equation. Can you tell me what was that? Theta is equal to, what was that? What was theta in terms of r? I think that was 24. 24 minus 2r over r, है ना? So you put r as 6 over here. This is 24 minus 12 over 6. So your theta is going to be, this is 12 over, that is 2 radians. This is the angle at which you get the maximum area. So in a way, this question, by the way, had nothing to do with the differentiation. So by mistake, I have done that. I thought that this question is on differentiation. But nevertheless, that made you revise, recall all your circular Mayer and then quadratics and all that. Okay, the ninth question, the same paper. Equation is y equal to x cube plus px square, where p is, remember, p is positive constant, okay? We might need this information. So it says, show that the origin is a stationary point, okay? So that means you must get 0, 0. So let's differentiate this. Let's differentiate. This is dy by dx. That is 3x squared plus 2px. And you put that equal to 0. And then you take x as common. This is 3x plus 2p. So one x equal to 0. The other is x is minus 2p over 3. If you put that x back into the equation, you get y equal to 0 as well. So you see, this is showing your origin here, okay? And then if you put this one in your equation, you get minus 2p over 3q, and then plus p into minus 2p over 3 square. So guys, this is minus 8 over 27pq, and this is 4p square, 4p cube over 9. Okay, your LCM is 27. So minus 8 and then plus 12. Is that 4p cube over 27? Yes, Pacho? So we have these two stationary points. One is 0, 0. The other is minus 2 minus 2p over 3 comma 4p cube over 27. Okay, so it says show that the origin is a stationary point. But it is really a great idea to read the question again after completing that. So it says, because sometimes we really miss that what had to be found. Okay, show that the origin is a stationary point. Yes, we've shown that. And find the coordinates of the other stationary point in terms of p. We have done that. Okay. It says find the nature of each of the stationary point. Okay, so this means we need to differentiate this again. Okay, so let's find for the second part, let's find the second derivative. So your d2y by dx square is going to be 6x. I'm differentiating this one, okay? So 6x plus 2p. Now here that information comes in action that, this p is a positive constant. So at x equal to 0, your d2y by dx square is positive, है ना? Because you're only left with the 2p. So therefore, 0, 0 is the minimum point. Okay? And similarly, at x equal to minus 2p over 3. So this d2y by dx square is equal to 6 into this will be minus 4p, and then you have plus 2p. That is minus 2p. So that is negative because p is positive. Minus into plus is going to be minus. Therefore, this minus 2p over 3 comma 4p cube over 27 is the maximum point. ठीक है बच्चों? Got it? क्यों भाई? Hello.
Yes, sir.
Okay. Now the last part. We in the last part it says find the. Sorry,
Yes, sir.
we have done. Okay. It says another curve has equation this. Find the set of values of p for which this curve has no stationary points. Okay, a clever question. I doubt he must have mixed the discriminant thing with it. Let's check that. Okay. Um, it's blue would work on it. Yes. Okay. So we have y equal to x cube plus px squared plus px. We find dy by dx and we get 3x squared plus 2px plus p. When you put that equal to 0, this equation should have, you see, real solutions if it has to have a stationary point. But it says it has no stationary point. So should I say that the discriminant of this equation should be negative? क्यों भाई? है ना?
Yes, sir.
है ना? Because it is a quadratic equation.
क्या आपकी आवाज बहुत ज्यादा ब्रेक हो रही है?
Why it is happening? Because I have really a stable connection here. So this is 4p.
मुझे आपकी समझ नहीं आ रही.
Okay, just let me complete that. I'll tell you again. Okay, so it's 4p square minus 4 into 3 into p that is less than 0. So we have kept the discriminant negative because there was no stationary point. No stationary point mean no solution for this derivative. Okay, so this is going to be 4p square minus 12p is negative. I have to take 4p common. This is going to be p minus 3 is negative. So remember, when there is a less than wala mark, so your p is going to be between the two values. One is 0, the other is 3. And if there was a greater than sign, then this set of solution would be on these two values. So guys, you see that how in an exam question, how whole of your syllabus is being tested simultaneously. ठीक है ना? So that is it from this session on the past papers from the differentiation.